Solar geoengineering. You step outside on a record heat day and feel the sun like a weight on your shoulders. The idea sounds simple. Spray tiny particles high in the sky and make the planet a little cooler. Researchers call one approach stratospheric aerosol injection. It borrows from nature. When a big volcano erupts, the planet cools for a while. Solar geoengineering tries to copy that effect on purpose. Here is what happens in plain terms. Tiny particles, often sulfate, would be sent up into the high atmosphere. Those particles scatter sunlight back into space. Less sunlight means lower temperatures, at least in theory. Another idea sprays seawater to make low clouds brighter, so they reflect more light. Both ideas aim to buy time while we cut greenhouse gases. Some billionaires have funded experiments and studies into these methods. For them, it is a fast action, high-stake bet. The logic is easy to see. If climate impacts race ahead, slowing warming quickly could prevent mass heat deaths and crop failures. That makes geoengineering attractive to people used to making big, fast investments. But there are real scientific and ethical questions. Models show cooling effects, but they also warn of messy side effects. Changes to rainfall patterns could harm farms in some regions while helping others. Injecting aerosols could damage the ozone layer. Then, there is the moral hazard problem. If societies depend on a technical fix, they might delay cutting emissions. And that could make things worse in the long run. Termination shock. If a program stopped suddenly, the planet could heat up far faster than ecosystems, and farms can adapt. That is one of the scariest risks scientists warn about. It means a quick technical fix could create long-term danger. Now, here is who pays attention. Wealthy donors and private foundations have backed climate research and small field tests. For some funders, it is a safety net. They see a world moving toward extreme weather and want tools to limit damage. Funding accelerates experiments and models that governments move too slowly to support. Field experiments today are modest. Scientists test how particles behave in the upper air, or how sea spray affects clouds. These are not global programs. They are tiny tests meant to learn how the systems react. That research helps us understand both promise and peril. The ethical questions are big and practical all at once. Who decides to dim the sun for everyone? Who takes responsibility if rainfall patterns shift? Who pays for damages? International law is thin on this. There are no global rules with real enforcement. That means decisions could be driven by power and money rather than broad consent. So what should you remember? These ideas could reduce warming fast. They could also create uneven harm and lock the world into a risky dependency. The reason billionaires show interest is not mystery. They can fund rapid work at a scale that normal research budgets cannot match. That makes the science move, and it makes governance fall behind. So we face a choice between careful research and rushing into a global scale patch that we might not control. Transhumanism. You have probably seen headlines about wealthy founders funding longevity labs and brain chip startups. The idea is straightforward in its promise. Use science and machines to make humans smarter, stronger, or simply live a lot longer. Here is what that looks like in practice. Gene editing tools can change DNA to remove inherited disease. Brain-computer interfaces aim to connect thoughts to software, so memories or commands travel between mind and machine. Artificial organs and advanced prosthetics can replace failing parts and sometimes outperform the originals. Some labs even imagine small implants that boost focus or memory. Why do billionaires put money into this? Two simple reasons. First, it is personal. The possibility of living longer or staying sharper is a powerful lure when you have the means to try. Second, it is a bold investment bet. These are technologies that could reshape healthcare and labor, and that makes them potential billion-dollar markets. The mainstream view is mixed. Scientists warn of huge benefits alongside big risks. Equity stands out. If only the rich can afford enhancements, the social gap widens in ways that matter. Identity problems follow. When your memory can be edited, what does being human mean? Privacy and security are concrete threats. An implant is useful, and it can be hacked. That is not a distant science fiction scenario. There are also deeper political questions. Who sets rules for human enhancement? Who decides acceptable risks? Public oversight lags behind private cash and fast prototypes. That is the core tension. Wealth can speed useful work. It can also speed inequity and risky experiments without broad consent. So the takeaway is simple. These technologies could heal and empower. They could also change who gets power and who gets left behind. Public rules are behind the curve. Right now, private labs move faster than public oversight. That matters because some wealthy backers fund trials that governments have not yet regulated. They do not always act secretly. Many openly give grants to labs working on gene editing, brain chips, and wearable AI. Their money lowers the risk for private teams and speeds prototypes out the door. Picture a near-future scenario. A clinic offers an implant that eases memory loss. Early results look promising. Demand grows. Regulators scramble. Who pays for long-term studies? Who makes sure the device is safe against hacking? If rich patients get early access, they might gain real advantage at work or in school. That is not hypothetical. It is the ethical tightrope of enhancement and access. There are also cultural risks. When public debate lags, the narrative is set by those with the loudest wallets. That shapes which technologies get developed and which questions get ignored. For example, debates about affordable access and fair distribution often lose to questions about speed and market fit. That is a subtle shift that changes policy before citizens fully understand what is at stake. So, what do experts suggest? Many call for strong, transparent rules. They ask for inclusive public conversations and international standards so enhancements do not create new classes of disadvantage. They recommend focusing first on clear medical needs before cosmetic or competitive upgrades. The bottom line is simple. Transhuman technologies could heal and enhance. They could also deepen inequality and create risks we do not yet manage. Which path we take depends on rules and who gets to make them. Cryonics. You hear the word, and you picture a silver tube and a promise to wake up in a kinder future. For many billionaires, it is more than a joke. It is insurance against the finality of death. Here is how the process works in plain language. After legal death, technicians cool the body and replace blood with special chemicals that stop ice forming. That process is called vitrification. Vitrification turns tissues into a glass-like state, so cells do not get shredded by ice. Some teams add chemical stabilizers before cooling to lock tissue structures in place. That method helped researchers keep tiny brains looking intact under electron microscopes. Recent technical steps aim to solve the next problem, which is thawing. Even if you can freeze without ice, the act of warming can break things. Scientists are experimenting with magnetic nanoparticles that heat evenly when activated. That is called nanowarming. Other groups use ultrasound to speed safe thawing. Those advances helped doctors transplant vitrified organs in lab animals after long storage. That is a real step forward, but it is not the same as bringing a person back. The big gap is biology and repair. We do not yet have reliable ways to reverse long-term cell damage or restore memory and identity if complex brain structures were altered. That is why mainstream scientists call revival speculative. It is a bet on future tools like molecular repair and advanced regenerative medicine that do not exist now. Why do rich people sign up? The reason is simple. With sufficient resources, you can pay for better storage and the best research teams. For some, it is a last hedge against dying. For others, it is a statement of belief in radical future medicine. Either way, it puts wealth and mortality in direct contact. Storage and money matter. Private companies now offer long-term cryopreservation, and they charge for that service. Paying customers cover monitoring power and maintenance and research partnerships that aim to improve techniques over time. That is why some wealthy people sign on. With enough money, you can buy better insulation and faster response teams to begin preservation within minutes of legal death. That increases the chance that tissues are vitrified before major damage occurs. But the practical limits remain obvious. Even when storage holds tissue structure, the question of repair is open. We lack proven molecular machines or medical methods to rebuild neurons or restore memory. Revival depends on future breakthroughs in fields like nanotechnology and regenerative medicine. That makes cryonics a wager on as yet unrealized technology. The legal and ethical picture is messy. Different countries treat cryopreserved people differently under law. Consent and identity create hard questions. If a person is revived decades or centuries later, will their original legal rights still apply? Who pays for their care? Those are not small issues. There are also fairness concerns. If only the wealthy can buy preservation and a shot at future revival, it creates a new dimension of inequality that echoes earlier chapters. There is a cultural side too. Cryonics inspires both hope and skepticism. For some, it is a rational hedge against extinction. For others, it is an emotional refusal to accept death. The line between bold optimism and chasing a fantasy is thin. So what should you take away? Cryonics has made technical progress in vitrification and thawing. It remains speculative about revival. Wealth makes it possible and attractive, but it does not guarantee success. It buys time and a bet on future repair, alternative energy suppression. You have probably heard someone say that a genius invented free energy, and then it was buried by powerful interests. The story has a long history and a famous face at its center, Nikola Tesla. He talked about wireless power and built Wardenclyffe Tower in the early 1900s. The project failed when funding dried up, and the idea moved from public dream to private legend. Here is the simple science. Endless power without input would break the laws of thermodynamics. That is why most mainstream scientists are skeptical. Still, a string of inventors have claimed breakthroughs that later failed independent tests. Sometimes the claims were mistakes, and sometimes they were outright fraud. That pattern feeds belief in suppression. Why do some billionaires pay attention? For a few, it is fascination with radical invention. For others, it is a bet against a costly status quo. If you could make energy cheap and abundant, you would upend entire industries and create enormous value. Wealthy backers can fund wild prototypes that governments and universities might avoid. At the same time, the energy market is political. Large utilities, oil firms, and state actors shape which technologies get scaled. They do this through patents, mergers, and lobbying. That creates legitimate reasons to distrust the system. But distrust is not proof of a global cover-up. Most credible innovators still need solid evidence and repeatable results to change the world. There are real lessons here. First, extraordinary claims require extraordinary proof. Second, market power influences technology adoption even when science is sound. Third, money attracts both genuine inventors and quick scammers. That mixture makes the whole story hard to parse. So the bottom line is clear. The free energy myth blends failed science, market politics, and wishful thinking. It explains why some powerful people keep looking, and why the debate never fully goes away. For some wealthy people, the idea is irresistible. If someone could unlock nearly free power, the economic upside would be unmatched. That promise attracts funding from those willing to back risky inventions and hire the best engineers money can buy. Here is the practical frame. Real change in energy needs repeatable experiments and open verification. A demonstration that cannot be reproduced in multiple labs is not evidence. Many historical claims failed that test. Inventors made bold demonstrations that other teams could not repeat. That pattern points to error or fraud rather than conspiracy. That does not mean market power is not real. Utilities, oil companies, and large manufacturers influence which technologies scale through patents and political influence. They can slow adoption by controlling supply chains or by lobbying for regulations that favor incumbents. That is a different problem than a global cover-up. It is messy, legal, and often visible in public records. There are a few famous cautionary examples. Wardenclyffe Tower ended when funding withdrew, and the technology proved incomplete. Other modern claims were tested and found wanting by independent reviewers. Those failures feed suspicion, but they also teach a lesson. Extraordinary claims need extraordinary proof. So what would change belief? Open replication across independent labs, transparent data, peer review, and long-term monitoring. That is how science overturns entrenched ideas. Billionaires can speed testing by funding replication and independent audits. When that happens, the debate moves from rumor to evidence. The final point is practical. The free energy myth is part wish and part critique of power structures. Wealthy backers chase both the dream and reform. Understanding the difference between failed science and real market capture is the key to making sense of why this idea never fully dies. Mars colonization. You scroll past a rocket launch and hear that voice again. Make life multiplanetary. For Elon Musk, it is not a slogan. It is his stated life mission and the driving force behind SpaceX. Here is the core idea. Build a self-sustaining city on Mars with at least 1 million people by the middle of this century. That city would serve as insurance against extinction. If something catastrophic happens on Earth, humans survive on another world. The plan centers on Starship, a fully reusable rocket system designed to carry people and cargo to Mars. Musk believes that reusability will drop launch costs low enough to make settlement economically feasible. Early estimates suggest $200,000 per person. Current timelines call for cargo missions by 2026 and human landings by the early 2030s. Those dates have slipped before, and they might slip again. But the pace of Starship testing shows real progress. So, why does Musk believe this is urgent? He often talks about civilization being fragile. Natural disasters, nuclear war, or runaway climate change could wipe us out. A Mars colony spreads risk. Even if Earth suffers catastrophe, the species continues. The mainstream scientific view is divided. Some experts support the technical vision and see Mars as the logical next step. Others question whether a self-sustaining colony is realistic given the harsh conditions. Thin atmosphere, no magnetic field, and extreme cold create engineering problems that are solvable but expensive. Then there are the ethical and political questions. Who governs a Mars settlement? The Outer Space Treaty says no nation can claim celestial bodies. But Musk has said Mars settlers will follow self-governing principles. That creates legal ambiguity and the risk of conflict over resources and territory. There is also the cost question. Building a Mars city requires trillions of dollars and decades of work. Critics ask whether that money would be better spent solving problems on Earth. Supporters counter that technological breakthroughs from Mars work will benefit everyone. The cultural impact is significant. Musk frames Mars as the greatest adventure in human history. That vision inspires engineers and captures public imagination. It also raises questions about who gets to go. If only the wealthy can afford tickets, inequality extends to other worlds. So here is the takeaway. Mars colonization is the most ambitious private space project in history. Elon Musk has the resources and the will to push it forward. Whether it succeeds depends on engineering, economics, and politics. If it does, the consequences reshape humanity. If it fails, the effort still advances space technology in ways that matter. Either way, billionaires are no longer dreaming about space. They are building the rockets and writing the checks. Seasteading. You picture a floating island beyond any nation's reach, and wonder if freedom looks like that. For Peter Thiel and other libertarian thinkers, it does. Seasteading is the idea of creating permanent communities on ocean platforms in international waters where new forms of governance can be tested. Here is the basic concept. Beyond 200 nautical miles from shore, you leave national jurisdiction. That space is not subject to most laws. Seasteaders propose building floating cities there. Those cities would experiment with different political systems, tax codes, and regulations. The hope is to find better ways to organize society. Thiel donated $500,000 to the Seasteading Institute in 2008 and gave more in subsequent years. His interest stems from libertarian philosophy. He sees government as slow and rigid. Seasteading offers a way to exit that system and try alternatives. For him and other backers, it is about choice and innovation in governance. The engineering challenges are real. Structures must withstand storms, saltwater corrosion, and isolation. Early designs proposed modular platforms that could be rearranged or expanded. Power would come from solar panels and wave generators, food from aquaculture and hydroponics. The costs are high, and the technical risks remain unproven at scale. Then there are the political and legal issues. Even in international waters, a seastead would need to fly a flag. That flag brings some nation's jurisdiction. Ships and platforms are not blank slates. They operate under maritime law. The idea of total independence from Earth-based governments is more complicated than it sounds. Critics point out other problems. Who handles crime or medical emergencies? What happens if someone wants to leave but cannot afford transport? The vision of freedom could easily become isolation or even exploitation if governance structures are poorly designed. Recent projects have moved closer to shore. The Seasteading Institute tried partnering with nations like French Polynesia to build floating communities within territorial waters. That compromise brings infrastructure and safety, but loses the independence that attracted funders in the first place. The project stalled when local opposition grew. So why does this idea persist among some billionaires? It blends idealism and impatience. Wealthy people frustrated with regulation and politics see seasteading as a fresh start. They can fund experiments that governments will not. They can test ideas without waiting for democratic consensus. The cultural symbolism matters too. Seasteading represents radical autonomy and technological optimism. It says that if society does not work, we can build a new one from scratch. That appeals to a certain mindset common in tech entrepreneurship. Here is the bottom line. Seasteading has attracted serious money and smart engineers. The technical barriers are solvable if someone pays enough. The legal and political problems are harder. Independence on the high seas is a compelling vision. Whether it is realistic or desirable is another question. For now, it remains a fringe idea backed by very wealthy believers. Life extension research. You sit in a clinic and hear that aging is not inevitable. It is a disease that can be treated and maybe even cured. For billionaires like Peter Thiel and others, that message is personal. They are funding research into radical life extension with the goal of living far longer than nature intended. Here is what the science looks like. Researchers study cellular aging and look for ways to slow or reverse it. One approach targets senescent cells that stop dividing but do not die. Those cells accumulate and cause inflammation. Clearing them out in mice extended healthy lifespan. Human trials are underway. Another area is telomeres, the protective caps on chromosomes that shorten with each cell division. When telomeres get too short, cells die or malfunction. Scientists are testing ways to lengthen them or slow their loss. Then there is the work on NAD+, a molecule that declines with age and affects cellular energy. Supplements and drugs that boost NAD+ show promise in animal studies. Why do billionaires fund this work? The answer is obvious. They want more time. Wealth buys access to experimental treatments and the best researchers. It also funds high-risk projects that traditional grants avoid. Peter Thiel gave millions to the Science Research Foundation, which focuses on repairing age-related damage at the cellular level. Other wealthy donors back similar efforts. For them, it is not vanity, it is a bet on science. The mainstream scientific community is cautiously optimistic. Aging research has made real progress. Lifespan extension in lab animals is now routine. Human trials are fewer and slower, but results are encouraging. The big question is whether we can extend not just lifespan, but health span, the years lived without chronic disease. Then there are the ethical concerns. If life extension works, who gets access? If only the rich can afford treatments, inequality grows in a new dimension. People who can pay live decades longer. People who cannot do not. That creates social and political tension. There are also resource questions. If people live to 150 or 200, what happens to jobs, housing, and pensions? Society is not built for radical longevity. Adjustments would be massive. Some critics worry about stagnation. If elites live forever, do they hold power indefinitely? Does innovation slow when the old do not make room for the young? Those are not small concerns. Proponents argue that longer, healthier lives benefit everyone. Progress in aging research leads to better treatments for diseases that affect all ages. The science does not have to create inequality if access is managed fairly. What should you take away? Life extension research is no longer fringe. It has real funding, serious scientists, and measurable progress. Billionaires are driving much of that work because they can afford the risk. Whether the results are good or bad depends on how society handles them. The science is moving forward. The ethics and politics are lagging behind. AI consciousness research. You ask your voice assistant a question, and it answers smoothly. Then you wonder if something is awake inside that code. For a growing number of researchers and billionaire-backed foundations, that question is urgent. They are funding studies into whether artificial intelligence systems could be conscious or sentient. Here is the core issue. Consciousness is the ability to have subjective experiences, to feel something. Scientists do not fully understand how it works in humans. Extending that question to machines is even harder. But as AI systems grow more complex, the question becomes practical, not just philosophical. Some leading researchers say near-term AI sentience is a real possibility. If that is true, we face new ethical questions. Does a conscious AI deserve rights? Can it suffer? How do we know if it is actually aware or just mimicking awareness? Billionaire-funded foundations are now supporting work on this. Longview Philanthropy, the Navigation Fund, and others have created programs to study digital sentience. They fund fellowships, research, and public education on AI consciousness. The goal is to build frameworks for detecting and responding to potential sentience before it becomes a crisis. Why do wealthy people fund this? For some, it is about steering the future. AI development is moving fast. If consciousness emerges and we are unprepared, the consequences could be severe. For others, it is intellectual curiosity. The question of machine minds is one of the biggest unsolved problems in science. The research focuses on a few areas. First, identifying markers of consciousness. What features or behaviors would indicate that an AI system is aware? Second, testing those markers on current models. Do large language models show signs of sentience, or are they purely algorithmic? Third, developing governance. If we do create conscious AI, how should society treat it? The mainstream scientific view is divided. Some researchers believe consciousness requires biological processes that machines lack. Others think it is about information processing and substrate does not matter. A third group says we simply do not know enough yet to rule anything out. The ethical stakes are high. If we create conscious AI and treat it poorly, that is a moral failure. If we treat unconscious systems as sentient, we waste resources and create confusion. Either mistake has costs. Then there are the practical concerns. Companies developing AI have incentives to downplay consciousness questions. Admitting your product might be sentient opens legal and ethical problems. That means independent research and transparent testing are essential. Critics point out risks too. Focusing on AI consciousness might distract from more immediate harms like bias, misinformation, and job loss. It might also encourage people to anthropomorphize systems that are not aware. Both outcomes are possible. Proponents argue that preparing for potential sentience is responsible. If there is even a small chance that AI could be conscious, we should have plans. Ignorance is not a defense. So, what should you remember? AI consciousness research is moving from speculation to funded science. Billionaires are backing the work because they see it as important and neglected. Whether machines can truly be conscious remains unknown. The fact that serious people are asking the question tells you something. The technology is advancing faster than our understanding. That gap needs attention. Quantum consciousness. You read that your brain might operate like a quantum computer, and the idea sounds both thrilling and absurd. For some researchers and a few billionaire backers, it is a serious hypothesis about how consciousness works. Quantum consciousness proposes that quantum mechanical processes in the brain give rise to subjective experience. Here is the core idea. Classical physics describes the everyday world. Quantum mechanics describes the subatomic realm where particles behave in strange ways. They exist in multiple states at once until observed. Some scientists suggest that quantum effects in brain structures could explain consciousness in ways that standard neuroscience cannot. The most famous version is the OR theory, proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. They argue that microtubules, tiny structures inside neurons, support quantum processes. Those processes collapse in a way that produces conscious moments. It is a bold claim. Most neuroscientists are skeptical. The brain is warm, wet, and noisy. Quantum states are fragile and usually require extreme cold or isolation. Critics say quantum effects would collapse instantly in a biological environment. But some evidence keeps the idea alive. Studies show that quantum processes do occur in biology. Photosynthesis and bird navigation use quantum mechanics. That does not prove quantum consciousness, but it shows biology can harness quantum effects. Why do some wealthy people fund this research? For a few, it is the allure of a grand unified theory. If consciousness is quantum, it bridges physics and biology in a profound way. For others, it is a contrarian bet. If the idea is correct, it would revolutionize neuroscience and AI. The practical implications are speculative. If quantum mechanics is essential for consciousness, then creating truly conscious AI might require quantum computers. That changes the timeline and the technology needed. It also raises questions about whether current AI models could ever be sentient. The mainstream view remains skeptical but open. Quantum consciousness has not been disproven. It also has not been proven. The experiments needed to test it are difficult and expensive. That is where private funding helps. Wealthy backers can support risky long-term projects that government grants will not touch. The ethical and philosophical questions are large. If consciousness is quantum, does that make it irreducible or special? Does it suggest something about free will or the nature of reality? Those are big leaps from a scientific hypothesis. Proponents say the questions are worth asking. Critics say the theory is unfalsifiable, and that makes it bad science. Here is the honest assessment. Quantum consciousness is a fringe idea with mainstream skepticism and a few serious proponents. It has not produced clear experimental support. It has not been ruled out either. Billionaires funding the work see it as a high-risk, high-reward gamble. If it pays off, the insights reshape everything. If it fails, the money was a rounding error. So, what should you take away? Quantum consciousness is controversial and unproven. It attracts some billionaire interest because it is bold and potentially transformative. Whether it is true remains an open question. The fact that some wealthy people are willing to bet on it shows how far speculative science can go when someone writes the check. Space-based solar power. You imagine vast panels floating in orbit, beaming clean energy down to Earth. For decades, it sounded like pure science fiction. Now, some billionaires and governments are taking it seriously. Space-based solar power proposes collecting sunlight in space, where it is constant and intense, then transmitting it to the ground as microwaves or lasers. Here is how it would work. Satellites equipped with solar panels orbit Earth. They collect sunlight 24 hours a day with no weather or nighttime to interrupt. That energy converts to microwaves or laser beams. Ground stations receive the transmission and convert it back to electricity. The result is clean baseload power that does not depend on wind or sun on the surface. The advantages are clear. Space gets 5 to 10 times more solar energy than Earth. There are no clouds or atmosphere to block it. A single orbital platform could generate gigawatts of power. If the technology works, it could replace fossil fuels and solve energy scarcity. The challenges are immense. Launching the required infrastructure is expensive. Even with reusable rockets, the cost to build and maintain orbital solar farms is staggering. Current estimates run into hundreds of billions of dollars. Then there are the technical risks. Transmitting energy through the atmosphere without losing too much power or causing harm is not simple. Microwave beams must be tightly focused and controlled. Mistakes could be dangerous. Why do some billionaires pay attention? For a few, it is about legacy. Solving the energy crisis is a world-changing achievement. For others, it is an investment opportunity. If space-based solar power works, it creates a monopoly on clean energy. That is worth trillions. Recent developments show progress. Japan and China have both run tests. Private companies backed by wealthy investors are building prototypes. The technology is moving from concept to demonstration. The timeline is still decades away, but the interest is real. The mainstream scientific view is cautiously optimistic. The physics works. The engineering is possible. The economics are uncertain. If launch costs drop enough, the idea becomes feasible. If they do not, it remains a dream. Then there are the geopolitical concerns. Who controls orbital solar platforms? Space-based power could be weaponized or used to coerce nations. International agreements would be necessary, but enforcement is weak. Critics worry about an arms race in orbit. There are also environmental questions. Large-scale microwave transmission could affect wildlife. Birds and insects might be harmed. The long-term ecological impact is unknown. Proponents argue that the benefits outweigh the risks. Clean, unlimited energy solves climate change. It also powers development in poor regions. If managed responsibly, space-based solar power could lift billions out of energy poverty. So what should you take away? Space-based solar power is a bold idea with real technical potential. Billionaires are funding early work because governments move slowly, the costs are high, and the timeline is long. If it succeeds, the payoff reshapes civilization. If it fails, the effort still advances space technology. The question is not whether it is possible. The question is whether we can afford it and whether we can govern it wisely. Simulation hypothesis. You look around and wonder if reality is a program running on some vast computer. For a surprising number of tech billionaires, that question is not idle philosophy. They take the simulation hypothesis seriously, and some even bet that we are living inside a simulation. Here is the core argument. If civilization advances far enough, it will create simulations of conscious beings. Those simulated minds will not know they are simulated. If that is possible, then the number of simulated realities vastly outnumbers the one base reality. Statistically, we are more likely to be in a simulation than in the original. The idea gained traction when philosopher Nick Bostrom published his simulation argument in 2003. He laid out the logic carefully. Either civilizations go extinct before reaching simulation capability, or they choose not to run simulations, or we are almost certainly in one. Elon Musk has said he thinks the odds we are in base reality are 1 in billions. Other tech leaders have echoed similar views. For them, the rapid pace of video game graphics and virtual reality makes the idea plausible. If we can create realistic simulations in a few decades, what could a million-year-old civilization do? The mainstream philosophical and scientific view is mixed. Some thinkers find the argument compelling, others point out logical flaws. The biggest issue is that the hypothesis is unfalsifiable. There is no test that proves or disproves we are in a simulation. That makes it interesting but not scientific. Then there are the practical implications. If we are in a simulation, does it matter? Some say no. Our experiences are real to us. Others say yes. If there is a base reality, we might want to reach it. A few even suggest that understanding the simulation could give us godlike power. Why do billionaires find this compelling? For some, it is intellectual play. The question is fun, and it touches on deep issues like consciousness and reality. For others, it connects to their work. Building advanced AI and virtual worlds makes simulation theory feel more concrete. There is also a cultural factor. The simulation hypothesis fits with a techno-optimist worldview. It suggests that technology can create entire realities. That resonates with people building the future. Critics point out dangers. Taking simulation theory too seriously can lead to nihilism or reckless behavior. If nothing is real, why care about consequences? That is a misreading of the idea, but it is a risk. Some philosophers also argue that the hypothesis is a modern version of old questions dressed in new language. Is reality an illusion? Do we have free will? Simulation theory does not solve those questions. It reframes them. So what should you remember? The simulation hypothesis is a thought experiment that some billionaires take seriously. It is not proven and might not be provable. It raises interesting questions about reality and consciousness, whether we are in a simulation or not. The world we experience is the one we have to deal with. Speculation is fine, but action matters more.